You're probably saying to yourself as you're going here, how is this different than the last ones? Okay. The reason was for the last type of equation that we dealt with, if I had an equation for it and I typed in T23, I would just sub in 23 and get it. For a recursive sequence, if I want T23, I need T22, which means I need T21, which means I need T20, which means I need T19, and so on. Okay? Computers love this stuff. Okay, computers can keep this up because they do it again and again and again. For us, if I were to ask you on a test to recursively find the 23rd sequence in a term, you're probably going to yell at me, okay? Because it's not going to be easy to find. You see the difference here? Okay, it's going to, you actually have to physically have the term before it. Okay. So think of this like the Fibonacci sequence we did for our warm-up here today. Well, think of this like the Fibonacci sequence we did for our warm-up, and we said it was based on adding the two numbers. If I were to say, what's the 50th term there? There's no actual mathematical equation to get there. You'd have to like add up all the pairs right until you get it like that. Right? So here we go. Example 1 says, find T4. Before we actually solve this question, I want to maybe explain a few things as far as the terminology. It says T1 equals 3. Can somebody tell me what T1 equals 3 means in English, please? Yeah, Luke, go ahead.
If you were to like list them all out.
Very good. T1, this is going to be the first term. The reason you need a starting point was because you can't base it on nothing. Like your sequence, if it has to use the previous term, you need a starting term to begin.
That's supposed to be T
to the n minus 1 is what it says. When it says Tn equals 4 times Tn minus 1, it means your current term which is Tn equals 4 times your previous term. Tn minus 1. Okay, so the previous term, second ladies please, the previous term is going to be Tn minus 1. So let's say we're looking, say n was 5, n minus 1 would be 4. Okay. So I'm going to start off here to find T4. That's what I'm looking for. If I were, let's start with T2 actually first of all. So T1 is going to be 3, which is given. Can somebody tell me how to set up T2, please? Luke is the only person awake. I'm sorry that I'm boring you today, guys. Okay, but we have to get this fundamentals, yes. The first day of a unit is just terminology. That's all this is. This is just understanding the fundamental stuff. We'll get to mathy stuff in a minute here. Okay, I'm sorry so quickly. I'm trying to show off all the features.
Guys, I kind of want you green eyes.
Okay, what's T2 going to be? Luke, I'm going to snub you right now. Sorry, I want someone else to snub you right now.
Then you put brackets around Tn minus 1.
No.
But you're multiplying.
That's right, yes. But there's no symbol stated, it's okay. Okay, what's T2 going to be, please? What's Tn minus 1, or what's n minus 1 going to be in this case?
2.
Okay, well, n is going to be 2, so n minus 1 is going to be?
1.
Good. Okay. Give me one last. Okay, which is going to be 4 times 3, which is going to be 12. Okay, can someone new?
Why?
Why is the T3? Because T1 is...
T1 is giving us 3 right here, right?
Okay.
And then T2 is going to, we're just going to use this equation for everything else. So T2 is going to be 4 times the one before it. 4 times
So would T3 be n or 4 T?
Okay, right? Because it's going to be one before. Only question or answer?
So it'll always be 4, like for this one, it'll always be 4 times 30, and then whatever term you're finding minus 1.
Yeah. So let's say, for instance, I want to find T99 here. Somebody give me the equation for T99. Yeah, Luke, go ahead.
4 times T minus,
Yeah, which is 298.
oh, so just if using the term before,
Yes,
that's
yes,
T,
yes.
I thought it was 4 times T times 98, but it's 4 times term number 9, okay.
Okay,
Right,
does
yeah.
that help? Clarify
Yeah.
things a little bit, I hope? Yeah, question?
So what's Fibonacci, whatever?
We'll deal with that, that'll come next. Let's
Okay.
start with the easy questions here first. That one's tricky. So you can see why this is tedious here. How do you find what T4 is going to be? Can someone new, please? What's the equation for T4? Sorry, you're out. Sorry, I got it. Somebody else, Summer, go. For T3. Which is 4 times 48, which is 192, is that right? Can someone confirm that for me? All right, nice, yeah. And you can see why this is less fun than the other methods, okay? Because this takes a long, long time to do. I'll give you one more of these to do, and then we're going to stop. So I won't do any homework on this tonight. Because I'll do another lesson on this tomorrow. So this is the tricky part. Here we go. T, example B. It's going to say T1 equals -3. Tn equals 5 plus 2 Tn minus 1. Okay, I'm going to help you out on a start by giving you the first term. T1 is equal to -3, which is good. Okay, can someone new, other than you guys know who the regulars are, they'll raise your hand 10 times this class, okay? Other than you, can somebody new give me the expression for T2, please? So, you know what, I'm going back to square root tomorrow, guys. You gotta try it. Please try. Please try. You're gonna live your out. Somebody new, please. Robin, you trying? Okay, well, the question, so I don't understand, I'll help you there, sorry. So all that n minus 1 means it takes whatever the subscript is here, and you're supposed to subtract 1 from it. Okay, so this one's going to be for T2. So all that happens is here, right, your n was 2 here, so n minus 1 is just going to be 1. Okay.
And on the last question, how do you get 48?
Oh, because what I did was I just used the value for it. So it says 4 times T1. T1 was actually equal to 3. So then it's 12. 4 times 3 is 4, right? So for 4 times T2, T2's value was 12, right? So 4 times 12 is 48.
Oh, okay.
And the same thing, then 48 just goes down there.
Okay.
All right, can somebody give me the expression for T3? I'm not actually going to do the numbers yet. What's the expression going to be? Kylie, go. Thank you. Okay, can I get a fourth volunteer? Somebody new, please, that haven't volunteered much. Lily, go ahead.
5 plus 2 T to the 3.
Now you can see why computers like this because it follows a pattern, right? Do the same thing again, again, and again. I know at least one person know how your computers are, who else is taking programming. But if you haven't got to recursion yet, you will, hopefully by the end of the year, okay, is to get to computers. Computers can do simple things very, very quickly. It takes them longer to do complicated things. Okay, let's find some numbers here. Someone be brave here and tell me how to find the value for T2. Yeah, go ahead, Julia. Be careful. It's not going to be 7 because, like, you know, like, right, the 2 is connected to the, yeah, so 5 minus 6 and -1. Right, because, right, the 2 is connected to the T1. Okay, can somebody else give me T3, please? I'm not going to pick on Colch's birthday. Everyone else in the class is their game, though. Go ahead.
5 plus 2 multiplied by -4.
Good. That's 5 minus 2, and it's going to be 3. All right, can I get a third volunteer to give me the last value here? Yeah, Owen, go ahead.
So it's 5 plus 2 times 30.
Okay.
And it's 11.
Okay. Good? Good? Yes, a little bit? Okay. For Luke, we're going to do Fibonacci. And then we're going to do, this is not your homework or anything, just play along here, please. So this is the last one. So let's see. T1 equals 1, T2 equals 5. Tn equals Tn minus 1 plus Tn minus 2. Okay, now before you're afraid, because this looks horribly frightening, okay, and I see one special case of bacterial after this, okay, do not be afraid. If Tn minus 1 is the previous term, can somebody guess what Tn minus 2 means? The one before that, okay? So if I were to write down, I'm going to write this in a sec, T100, what would T100 equal? Yeah, T99 plus T99 plus T98. So you get the logic there? Okay. So we're going to do the same thing here. T1 is equal to 1 because it's given. T2 is equal to 5, and that's also given. Yeah, it's up there. Okay, can somebody give me an equation for T3? Okay, good. N is equal to 3, so what's N minus 1 going to be? T2. Plus T1. Okay, hold on. Just slow down for a sec. Okay. So what I use for T3 is I just use this equation here, right? So N is equal to 3, right? So N minus 1, so just, right? So this, what I'm going to say is T2, well, this shouldn't be 1, let's say plus T1, I don't know what happened there. So T2 is equal to 5 plus 1 equals 6. All right, can somebody new give me an expression for T4, please?
So T3 plus T2.
Very good, awesome. T4 is T3 plus T2. See, there's patterns to all this stuff, right? It's just getting your head wrapped around it. Okay. T3 I have is 6. T2 I have is 5, and that equals 11. So that's what the Fibonacci is. The difference for Fibonacci is that I have T1 is 1 and T2 is 1. That's what Fibonacci is, right?
So is it still called the Fibonacci sequence even though T is 5?
Not necessarily. Okay. It's called recursive sequence. We'll get more into recursive stuff tomorrow. You know recursive homework, right? Okay, right? But solve the equation first. Can we finish off the math? Yay, math!
Yay, math!
Yay, English! That was from Mr. Hillier, a piece of, I hope Mr. Hillier's my